Let us name this organic compound structure step by step. First, identify and name the parent chain. Parent chain is the longest continuous carbon chain. We have to identify as well the number of bonds present in the parent chain. We have in here, let us count the number of carbons in the longest carbon chain. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 carbons, and we have to identify the number of bonds are present in this structure. So we have double bond or 2 bonds. So since we have 9 carbons, that is none, and then it has double bond, which is the alkene, and with the suffix of ene or in, combining them, it would be nonene. And then we have a locant, or the number of position in which the double bond is located. So the nearest double bond location is number 2, because we will be counting the lowest number possible of locant. So counting from right, we have 1 and 2. The locant of the double bond is 2, and then the parent name is nonene. So we have 2 nonene. Next is identify the substituent with locants. Substituents are attached to the parent chain, while locants are the numbers that define the positions of the substituents and double bond. We have substituent here such as the methyl and ethyl. Methyl consists of 1 carbon and another methyl here with 1 carbon. Ethyl has 2 carbons. So these are alkyl groups with the formula of CnH2n plus 1. Next is number the carbons in the parent chain that will give the lowest possible numbers of locants of substituents. Let us first identify the locants of the methyl. So we have here methyl. Since a while ago we have counted the lowest number possible for the double bond from right, so we have to be consistent to that. So we will be counting from right. So we have 1, 2, 3. So the methyl is located at the 3rd carbon, and then we will just count continuously for the other methyl. So we have 3, 4, 5. So we have 3,5-dimethyl. Di would be the prefix since there are 2 methyls. So we have 3,5-dimethyl. Next we have 4-ethyl, because the ethyl is located at the 4th carbon. So counting from right again, 1, 2, 3, 4. We have 4-ethyl. Let us combine now as one name the parent names and substituent with their locants. So locant and then prefix if it is available, and then substituent, and then the parent and the suffix. It will be in alphabetical order for substituent, excluding its own prefix. We have in here 4-ethyl, 3,5-dimethyl, 2-nonene. Again, alphabetical order, but we won't including in alphabetical order the prefix, which is di. Only have ethyl and methyl, so E comes first before M. So we have 4-ethyl and then 3,5-dimethyl, and then the locant for the double bond, which is 2, and then we have the parent name, which is nonene. So the complete name is 4-ethyl, 3,5-dimethyl, 2-nonene. To separate the number from letters, we use dash. To separate number from number, we use comma. And for letters, it is without space. Let us name the next structure present here. First step is to identify and name the parent chain. So again, parent chain is the longest continuous carbon chain, and we need to identify the number of bonds present in the parent chain. Let us count now the continuous carbon chain. So we have 1, 2, 3, 4, 5, 6. 6 carbons, and the number of bonds present in the longest chain is double bond. We have in here 6 for hex, and then double bond for ene. So that would be hexene. And the double bond is located in the 1st carbon, and that is why we also count from left, because that would give the lowest number possible in the locant. we have 1 hexene. So for writing 1, if the locant is 1, we can include or remove it. So it could be 1 hexene or hexene only. Next step, identify the substituent with locant. Substituents are attached to the parent chain, and locants are numbers that define the positions of substituent and double bond. Here we have the substituent, chloro and methyl. Chloro is halogen of the chlorine. Other halogen that could be seen in a structure could be fluorine as fluoro, bromine as bromo, and iodine as iodo. But in this structure, chlorine or chloro is present. As substituent, we call it as chloro. Another substituent present here is the methyl. So it is an alkyl group with 1 carbon and with the formula of CN, H2N plus 1. Next step, number the carbons in the parent chain that will give the lowest possible numbers of locants of substituent. Again, we have already numbered the lowest possible number of the locant of the double bond. So we will just follow the position of the double bond. So we counted or numbered it from left. So this time, let us count for the locant of substituent. So we have 1, 2. We have now the locant as 2 for chloro. So we have 2 chloro. Next would be the methyl. So let us count the locant for methyl. 1, 2, 3. We have 3 methyl. Let us now combine the parent chain and substituent. So again, it will be locant, and then if prefix is available, and then substituent, parent, and suffix. Alphabetical order for substituent excluding its own prefix. Combining them, we have 2 chloro, 3 methyl, 1 hexene. Chloro comes first in alphabetical order compared to methyl. So we have 2 chloro, and then 3 methyl, and then 1 hexene. So if the locant is 1, we can add or remove it. So it would be 2 chloro, 3 methyl hexene. So both are considered. So in separating numbers from letters, we use dash. From separating number from number, we use comma. And for letters, we don't use any space. We have a practice time in here, so you can pause for a while and try to answer on your own. And this would be the answer. So if you have a question, you can comment down below your questions and I will answer. Thank you so much.